Hello there, welcome to Mr. Cook's Fun Review video number 1. So we're going to do additional factoring practice and just run through a couple of random problems on here, sticking with our factoring algorithm that we learned in class. Okay, so put your name up there we go. Okay, so here we go, Mr. Cook, let's get to work here. So starting with number 1, let's see here, we got 15p squared minus 31p minus 24. So let's see here. I got to make sure that this is in standard form before I start the factoring process. Remember that standard form looks like this. Ax squared plus bx plus c equals 0. So notice some things in common, some things that are a little bit different. You know, the variables are different, but who cares? Like, as long as we have a variable squared and then a variable in the middle and then a constant value equals 0, then it's in standard form. These a, b, and c values are the constants and the coefficient values that are in front of the variables, and then, you know, the constant value right there. And it's also how we get to quadratic formulas. So, you know, keep in mind that they're going to come in handy in knowing all of those values, you know, even when we're not factoring. Okay, so when we want to start factoring, we want to establish what those values are and then go through the process of factoring. So the a value, the b value, and the c value are as follows. A in this case is equal to 15, b is equal to negative 31, and c is equal to negative 24. So let me preface this by saying that the majority of these problems are like way more challenging than anything that we would quiz you on or test you on. This is more just for I guess practicing your factoring skills, because it is important to make sure that you know the steps themselves, because no matter what the numbers lead you to or how many factors that you end up with, these steps are always going to be the exact same, no matter what you face, as long as it can be factorable. Okay, so let's work through this problem, see what we're working with here. So we've got, we make the x for our factoring, because we're doing the x factor, that's where the x comes from. We multiply the first coefficient, the a value, times the constant value, negative 24. So if we use our calculator and find out what that is, let's see here. So 15 times negative 24, and we end up with negative 360. Okay, so that's a familiar number. So they multiply together to be, I'm looking for two numbers when I'm factoring. I'm looking for two numbers that multiply together to be negative 360 and then add together to be this middle coefficient, this negative 31 right here. So from here, we've already established kind of like some clues as to what numbers that we're going to be looking for that go over here. They need to multiply together to be a negative number, negative 360, and they need to add together to be a negative number, negative 31. So the numbers that we're going to pick from, I mean, at this point you can pick any random pairing, obviously, but what you want to do is limit yourself to just all the factors of 360. So a factor, remember, divides in evenly to a number. So I'm just going to list off all the factors of 360. We couldn't have picked a better number than 360 because 360 has a ton of different factors. So let's list off all of the ones that we can think of, and maybe use our calculator to kind of speed the process along a little bit. So I'm going to keep my calculator handy and see what I can come up with. So I already know that 1 divides into 360 real easily, right? Because it's just 1 times 360. 360 is an even number, so it divides by 2 pretty easily. So 360 divided by 2. If I do that on my calculator, I end up with 180. And then you can check to see if 360 divides by 3 if you didn't know already. And there are divisibility rules, by the way, if you need those as well. I can tell you about some of the divisibility rules, maybe even make a video at a different date to, see some of those divisibility rules in action. Anyways, just keep going down the list as much as you possibly can. 360 divided by 4, we get 90. 360 divided by 5, we get 72. 360 divided by 6, we get 60. 360 divided by 8, we get 45. 360 divided by 9, we get 40. 360 divided by 10, we get 36. 360 divided by 11 doesn't work, but 12 does work. That's going to be 30. And then 360 divided by 13 doesn't work. 14 doesn't work, but 15 does work. It's going to be 15 and 24. Yeah, 24. And then 16 will not work. 17 doesn't work. 18 will work. It's 18 times 20. Okay, so these are all the different factors of 360. And you can use your calculator as much as you need to get to those factors as best as you can. So now let's take a look at the numbers themselves. So negative 360 is what these two numbers need to multiply together to be. The only way that numbers can multiply together to be a negative number is if one of them is positive, one of them is negative. So I already know that, like, the 1 might be negative and 360 might be positive, as like a possible pair. To help you to limit the different combinations of numbers, what you do is look at this second number over here. The numbers add together to be negative 31, so that implies that the larger of the two numbers that are adding have to be negative. So if you just look at the pairings of the numbers, the larger number always has to be negative. So just put a negative on the larger number in the pairs. And then when you're done with that, you should be able to figure out which one adds together to be negative 31. If you just add all the values together, you end up with 9 minus 40. That's the pair that we're looking for. That multiplies together to be negative 360 and adds together to be negative 31. So we put those two numbers over here, a positive 9 and a negative 40. And then we complete the factoring algorithm. So since we have a lead coefficient of 15, you just attach that onto the p when you have the rest of your factoring expression. So we've got 15p and then plus 9 from over here, so plus 9. And then we've also got 15p and then minus 40. So those are the two numbers. That's why we hunt them down, because that helps us to establish our factored expression, our binomials. Okay, so the last step that we need to do when we're factoring is divide out the common factor of the numbers that are in the parentheses. So the common factor between 15 and 9. So what number divides into both of these evenly? And that should be the number 3. That's the largest one possible. And then for 15 and 40, the largest number that divides into both of those numbers is 5. So we're going to divide out 5 from both of those numbers. Now, when we divide out the numbers, it's basically like distribution. We need to divide out the 15 by 3 and then also the 9 by 3. And then over here, the 15 needs to divide by 5 and the 40 needs to divide by 5 as well. So when we simplify this expression over here, we end up with 5p and then plus 3. And then over here, 15 divided by 5 is 3, so we get 3p. And then 40 divided by 5 is 8, so minus 8 equals 0. Now that we're done factoring, now we start the process of solving. And when we solve, we take each of these factors, these expressions that are in the parentheses, and we set them equal to 0 individually to solve for the p values. So we'll start off with the first one, 5p plus 3 equals 0. So if I want to get the p by itself, I subtract 3 from both sides first, so 5p is equal to negative 3. And then divide both sides by 5, so I get p is equal to negative 3 over 5. All right, and then the next one, 3p minus 8 equals 0. And then we add 8 to both sides, and we get 3p is equal to positive 8. Divide by 3 on both sides, and we get our other solution, p is equal to 8 over 3. So these are our two answers, negative 3/5 and 8 over 3. And you can test to make sure that these are your solutions by going back and plugging in for p if you have some time. Because if you plug in negative 3/5 for p, you should end up with 0. If you plug in 8/3 for p, then you should end up with 0. All right, so that's number 1. So now I'll go over like a couple other ones from this side and maybe a couple from this side as well. And yeah, that's it. So that's the end of this first video. Thank you.